when you have a negative times a negative, it's a positive. Now, in grade 10, we're focusing on the principal square root. You don't have to stress about doing the plus or minus. Okay, we'll be focusing mostly on the positive, but in grade 11, you'll be working with both. Okay? When you cubic root, can you square root a negative, by the way? Can you take the square root of a negative number? No. Right? Cannot. Cannot square root a negative number. Can you cube root a negative number? Yes. So if you're doing a square root, that's okay. Cube root, not okay. So let's move on to the bottom of this. Oh, did I open the right thing? Yeah, here it is. The bottom of this page. And let's use our we'll mentally as much as we can, but if we can't, we'll use our graphing calculators. Square root of 49, what's that equal to? 7, good. Does anyone know the cubic root of negative 64? Let's grab our calculators for this one. Cube roots are probably new to you, in the sense that knowing your perfect cubes. We're going to try and start to memorize those, but that's new for you. So what do I push? Math, number 4, negative 64. Okay, is negative 4. So you can cubic root a negative, you just can't square root. 4th root of 10,000. Now, a 4th root's really cool. It's the same thing as square rooting it twice. Okay, I'll show you. 4th root, how do I type in if I want to do the index of 4? The little number is 4. Math 5. So I'm going to actually push the 4 first, and then math 5. Okay. So the 4th root of 10,000 is 10. Okay. Now, I'll show you. It's the same thing as square rooting it twice. So 4th root is the same thing as square rooting it twice. Or square rooting 10,000 is 1,000, and then square root of 1,000 is 10. Okay? So it's the same thing. 5th root over 1 over 32. So let's try that one together. Yeah? Did you push math 5? Did you push 4 first? Yes. Yours, well, yeah, that's right. Looks like you forgot to. Yeah. No. Okay. That would be confusing. Okay. So 5th root, I'd have to push 5, then math, number 5, 1 divided by 32. Okay, and if we want to change something into fraction, well, that one we should be able to do in our head, 1 over 2, but you can also go math, enter, enter, and that will change your previous answer into a fraction. Math, enter, enter. Okay. All right, try E and F. Okay, so the first one, a 7th root, so I'd have to type the 7 first, and then I would math, for me, math 5, so you want the x root, and that should be the same button on scientific calculators too, just different spot. Negative 21,087, which is negative 3. Okay. Now some of you, when you type in this next one, the cubic root of 216 over 125, so math, number 4, some of you would need to put brackets around 216 divided by 125. Okay, if you're using a scientific, because with BEDMAS, we don't want to just cubic root 216, right? It's this whole fraction. So if you have this type of calculator, or even the 83 version, as long as your brackets are, if yours does, some of you give a bracket, right? If you push cubic root, it looks like this. Cubic root, bracket, It automatically opens a bracket. Then you type in 216 divided by 125, and then you close the bracket. Some of your calculators. Okay, what did that give you? What if I want that as a fraction? How do I do that? Math, enter, enter. 6 over 5, 1.2. So usually if the question is a fraction, we want to answer as a fraction. If the question was a decimal, then we can answer as a decimal. That's really, the question guides us on how we answer. Okay, B, the 6th root of 0.5 to the nearest hundredth. So 6 math 5, 0.5. So to the nearest hundredth, how many decimal places is hundredth? 2, because it's 1 divided by 100 is 2 decimal places. 0.89 you should have had. So 2/3 times 4th root. So I'm going to type my 4 first. Math number 5. 4th root of 1,000. So 2 decimal places. 3.75. Good. Careful of the rounding. So these are approximate because they're rounded values. Okay, let's talk about the very bottom of that page, some terminology, really important terminology. So I've been saying index, index, index. So you probably know now that's a little number that, if it's a square root, the index is 2. If it's a cube root, the index is 3. 4th root, index is 4. That little number is your index. What's inside? Oops. What's inside the square root symbol is called the radicand. So in this case, 29 would be your radicand. Everything underneath the square root symbol is the radicand. Okay? And then the whole thing is what we call a radical. And of course, this little weird thing is the radical symbol. Okay? So if you do not see the index, like root 30, the index is 2. Because you don't just write, we're lazy as mathematicians. If there's no little 2, we assume it's a 2. Okay? Because that's the most commonly used is square roots. So we don't see the index, it's a 2 automatically. And yeah, if the index is even, right? The index is even, radicand can only be positive. So the inside, you can't square root a negative, essentially is what I'm saying. You can't 4th root a negative. You can't 6th root a negative. It's just not possible. If your index is even, your inside of this radical symbol cannot be a negative. Okay? All right, so let's look at the next page. And here we go. So what's our index in the first one? 5. What's the radicand? 75. What's the index of B? If you don't see it, it's a little 2, square root. Okay, radicand would be 50. Okay. Next one, the index, 3. The radicand, -1/10. Everything that's underneath that symbol is the radicand. Okay. So to simplify radicals, we're going to learn how to take root 8 and turn it into 2 root 2 today. Okay? But before we do that, we need to learn a couple things. We need to learn some terminology. So the first thing is, if everything is under the square root, there's no number in front, this is what we call an entire radical. Entire radical. Let me write that again. It's really messy. This is what we call an entire. So an entire radical is when everything is underneath the square root. And you'll see that definition again, more than once. Okay? If there's something in front, this is what we call a mixed radical. Like mixed fractions. Okay, that would be a mixed radical. Now a mixed radical, the 2 root 2 and root 8, are they the same thing? Well, grab your calculators. Type in square root of 8. Push enter. And then type in 2 root 2. Push enter. Are they the exact same thing? Yes. Now 2 root 2, the mixed radical, is the more simplified form. Root 8 is not the simplified form. So we're going to learn how we call it when we say simplify a radical. We're going to turn them into mixed radicals. That's what we're going to learn how to do. So one of the biggest properties we have to use is that, let's discover it. Root 9 times root 4. Type that into your calculator. So root 9, and then times, so get out of the square root, root 4 is 6, which makes sense. 3 times 2, right? Root 9 is 3, root 4 is 2, 3 times 2 is 6. Now, square root of 9 times 4, all under one square root. What's 9 times 4? 36. What's the square root of 36? 6. Those are equal to each other, okay? These are equal. So that's really important. That's going to lead into a whole bunch of stuff we do. Okay, root 9 divided by root 4. Root 9 divided by root 4 versus root 9 over 4. Guess what? Same thing. 1.5. Okay, 3 over 2. Root 9 is 3. Root 4 is 2. 1 over 1.5. So those are equal. Okay. This is not true for addition or subtraction. Root 9 plus root 4 is not the same thing as square root of 9 plus 4. And same with subtraction. It only works for multiplication and division. And so that's where everything we do in the next few days is based on those two properties. That root A times root B is root AB, and root A divided by root B is the same thing as root A over B. Okay, that those are equal to each other. So we're going to say, is this true or not for each one of these? Root 3 times root 6, is that equal to root 18? True or false? True. Multiplication, that is true. If you need to check with your calculator, you're more than welcome to. Okay. Is root 20 divided by root 10 equal to root 2? Yes, that would also be true. And you can check. Could we check on our calculator? Sure could. If you're not sure, type it in. Oops, I forgot the division symbol. That's important. Is that the same thing as root 2? So we can actually divide that. 20 divided by 10 is 2. Root 2. True. How about addition? False. So what is 16 plus 9? That's 20. What's the square root of 25? 5. What's square root of 16 equal to? 4. What's the square root of 9? 3. Does 7 equal 5? Does not equal. This is false. Okay, so it does not work for addition or subtraction, only for multiplication and division. So if we know that, what is root 8 times root 3 equal to? Root 8 times 3, or root 24. So write each as falling as a single radical. So root 7 times 3 is the same thing as root 21. 7 times 3 is 21. Okay. Root 50 divided by root 10, well, we can put that all under one square root because it's division. What's 50 divided by 10? Root 5. Okay, this is a weird one. Let's just right now first tell me what is the square root of 100. What is the square root of 100? You should know that. Just 10. So instead we can write this as root 10 divided by root 2. So we just evaluated, I'll make it a little larger. We just evaluated root 100, this part here. So one of the square roots is gone, the other is still there. Now what can we do? Under one radical, and what's that equal to? Square root of that. missing something. There's another example, and it's not here. You have an example 7, right? Here, let's write it here. So example 7 says write as a product of radicals. Root 77, how could we write it as a product of two numbers? What two numbers could I break it into? 7 times 11. So if 77 is 7 times 11, how can I write that as two radicals? Root 7 times root 11. Could you write root 11 times root 7? Yeah, it's the same thing. Okay, root 27. What are two numbers that multiply to 27? 9 and 3. So I'd write that as root 9 times root 3. Good. And root 40? What, root 2, or 20 times 2? There's more than one way, right? So there's 20 times 2. So you could write it as root 20 times root 2. What else could we do? You could go root 10 times root 4. Is there any other ones? 5 times 8. Any other ones? I don't think so. That's it. Okay? All right. So, what are we doing for time? I'm going to split up this lesson into a couple parts because we're ahead of the other classes. So we can take our little, I'd rather take our time on this stuff than lowest common multiple and greatest common factor. That's what I chose to do. So there's supposed to be two parts, but I'm just going to assign page 36 right now. So if you can circle these numbers, page 36, which was C1, ACIJK, 2, 3 ace, 4 to 5 AB, 6 to 10, and 12. Okay. So I'm going to get you to work on that. Okay, and I'll end this here.